Solving systems of equations by matrices. So we have some terms and definitions, and I wrote them out ahead of time just because it's hard for me to write on my iPad. So if you look, terms and definitions, matrix. It's a rectangular arrangement of numbers written in brackets used to solve systems of linear equations. And you can see I put array in there. So we also call it an array, a rectangular arrangement or array of numbers written in brackets used to solve systems of linear equations. An element is each item listed in the matrix. Each element is numbered by its row and column. So just keep that in mind. Each element is numbered by its row and column. A row is a list of elements going across the matrix. Column is a list of elements going down the matrix. A matrice's dimensions are determined by the number of rows and columns. And like we said there before, dimensions, the number of rows and columns in a matrix. Coefficient, so if you remember, it's the number in front of a variable. So these are just some of the terms and definitions you'll have to keep in mind for solving systems of equations by matrices. And today on these notes, we're not actually going to solve any, we're just going to show you how to set them up. In my class, you have the back of this note sheet that has the directions for how to plug it into your calculator. So we're not going to do it by hand, but we'll be doing it by calculator. So first thing, you look at example 1, and this is a 2 by 3 matrix. 2 by 3. 2 rows, 3 columns. And as these are written, how you should write them should be bracket, line, bracket. This line, think of it as an equal sign. And we're going to label this as A. This is matrix A. So if I'm asking you to label different elements, so when we're talking about elements, I would say in matrix A, tell me what element 1 is. So that's telling you, saying, what is element 1, 1, which is row 1, column 1? That would be 2. If I said in matrix A, give me row 2, column 3, that would be here, row 2, column 3. Excuse me. So that would be 6. So when it has like A and followed by 2 numbers, that's the row and column numbers. And that's just asking you to find a specific element. Now, what the matrix is actually telling us is these columns are all variables. So left of the equal sign is variables, to the right is just a constant. So I always go with 2 variables, I always use x and y. So this would be 2x plus 5y, or sorry, minus 5y equals 13. And for the second row, it's negative 4x plus 3y equals 6. So you can see the coefficients, the matrix is made up of coefficients and constants. So the coefficients inside the matrix, when you're writing out the actual equations, you just use those same numbers for x and y. Or if you used A and B, C and D, whatever, it needs to be alphabetical order, but that's how you do it. So if we looked at example 2, and I asked you to find, first of all, you'd say this is a 2 by 4 matrix, 2 rows, 4 columns. I would say, what is element A13 if this is A? So A13, row A, or row 1, column 3 would be negative 2. If I said find A21, row 2, column 1, negative 1. So now we're writing our equations out. So with 3 variables, I usually use x, y, and z. You could use a, b, and c. Whatever you want, it'll work. So I'm going to say 4x plus 7y minus 2z equal, let me put the z in there, minus 2z equals 5. And so if you remember, we want these as brackets and a straight line through. So at 4x plus 7y minus 2z equals 5. And then I have negative x plus 0y, I don't even need to write that in, plus 4z equals negative 12. So you can see I didn't have to write down the y, but in the matrix I had a 0 for y. So inside the matrix you need to keep everything lined up variable wise. We don't just skip the variable if it's not in one but it's in the other. We still have to list it as a 0. It's very important to keep everything lined up inside the matrix. And then outside, if we have equations, like example 3, we have x and y, and we want to write it as a matrix. So first, I'm putting in my brackets and my equal to line. So my top line, 7x minus 3y equals 9. So 7x minus 3 equals 9. And then I have negative 2x, 12y is negative 5. So once again, we have to keep them lined up. X, x, y, answer. Okay? X, y, answer. So always keep them lined up in their columns. And so then on number 4, you can see we need to do some work to get these in the right side. So I need to take the x over here and the number over here. So I'm going to rewrite this as negative 5x minus 2y equals negative 4. Now with these, you could also, if I took out a negative 1, it doesn't change anything. It makes it 5x plus 2y equals 4. And in the matrix, it'll work the same way. If you have all negatives or all positives for those, they'll both work the same way. Then for the second one, I have 2x minus equals 9 with negative 9y. So I'm just going to make this 2x plus 9y equals 0. So now, when I write up my matrix, I have 5, 2, and 4. Or negative 5, negative 2, and negative 4. Either one will work. And then 2, 9, and 0. And so that's how you go from matrix form to equations and from equations back to matrix. All right, and that is, I'll show it all to you. That's solving systems of equations by matrices, and it's basically setting it up.